You spin this spinner and flip a coin. How many possible outcomes are in the sample space? List the possible outcomes. Flipping a coin can result in either heads or tails. If the coin flip results in heads, spinning the spinner can result in 1, 2, 3, or 4. If the coin flip results in tails, spinning the spinner can result in 1, 2, 3, or 4. So the sample space has 8 possible outcomes. They are heads 1, heads 2, heads 3, heads 4, tails 1, tails 2, tails 3, and tails 4. A coin is flipped 4 times. What is the probability that it lands on heads exactly 3 times? First, find the number of outcomes in the sample space. Let H represent heads and T represent tails. The possible outcomes are shown in the table. The probability that it lands on heads exactly 3 times equals the number of favorable outcomes divided by the total number of outcomes. Notice that there are 4 favorable outcomes with exactly 3 heads, and the total number of outcomes is 16. So the probability that it lands on heads exactly 3 times equals 4 divided by 16, or 1/4. So the probability that the coin lands on heads exactly 3 times is 1/4, or 25%. Find the probability of each event when 2 6-sided dice are rolled. Part A. The sum is greater than 8. Using the complement, the probability that the sum is greater than 8 equals 1 minus the probability that the sum is less than or equal to 8. Notice that 26 of the 36 possible outcomes have a sum that is less than or equal to 8. So the probability that the sum is greater than 8 equals 1 minus 26 divided by 36, which equals 10 divided by 36, or 5/18. 5/18 is approximately 278 thousandths. Part B. The sum is not 2. Using the complement, the probability that the sum is not 2 equals 1 minus the probability that the sum is 2. Notice that only one of the 36 possible outcomes result in a sum that equals 2. So the probability that the sum is not 2 equals 1 minus 1 divided by 36, which equals 35 divided by 36, or approximately 972 thousandths. You throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. What is the probability that your dart lands in one of the two yellow sectors in the smaller circle? The probability of landing on one of the smaller yellow sectors equals the area of the smaller yellow sectors divided by the area of the entire board. Note that the area of the smaller circle is pi r squared, where r is 2. So the area of the smaller yellow sectors is given by 1/2 pi times 2 squared. Notice that half the length of the board is 2 inches plus 3 inches, or 5 inches. So the length of the board is 10 inches, and the area of the entire board is 10 squared. So the probability of landing on one of the smaller yellow sectors equals 1/2 pi times 2 squared divided by 10 squared, which simplifies to 2 pi divided by 100, or approximately 63 thousandths. A spinner has 5 sections colored red, green, blue, yellow, and purple. Each section of the spinner has the same area. The table shows the results of 50 spins. For which color is the experimental probability of stopping on the color the same as the theoretical probability? Note that the theoretical probability of stopping on each of the 5 colors is 1/5. Use the outcomes in the table to find the experimental probabilities. Because the spinner stopped on red 5 times, the experimental probability of stopping on red equals 5 divided by 50, or 1/10. Because the spinner stopped on green 20 times, the experimental probability of stopping on green equals 20 divided by 50, or 2/5. Because the spinner stopped on blue 3 times, the experimental probability of stopping on blue equals 3 divided by 50. Because the spinner stopped on yellow 10 times, the experimental probability of stopping on yellow equals 10 divided by 50, or 1/5. And because the spinner stopped on purple 12 times, the experimental probability of stopping on purple is 12 divided by 50. So the experimental probability of stopping on yellow is the same as the theoretical probability. A spinner has 5. In the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them have at least one pet. The types of pets these adults have are shown in the figure. What is the probability that a pet-owning adult chosen at random has a bird? The results of the survey show that 93 of the adults surveyed have a bird. So the probability that a pet-owning adult has a bird equals 93 divided by 1,328, or approximately 70 thousandths. So the probability that a pet-owning adult chosen at random has a bird is about 7%.